And then we have seen what are the list implemented classes, set implemented classes. All right, today we'll see, before starting the map, right, we'll see a few more topics. All right, I think we have seen list iterator and iterator, and on the vector and stack, right, vector and stack, right, instead of iterator on the legacy collections, we can also, suppose if I create a one more vector, okay, fine, vector, right, we can call it as on the legacy classes. We have method called, what is that? Elements, right, elements. What it will return? It will return a enumeration elements, right? If you try to call on this, right, let's see, we cannot, because that is what is that method called? This is specific to vector, right? We cannot call on the interface reference, right? This is specific to vector, so we can call vector dot elements. What it will return? Enumeration, right? We can keep enumeration. Enumeration of what is the type? Integer, right? Integer. Right, enumeration. Right, here also we can do while enumeration object dot has more elements, and then next element. Has more elements, what it will do? It will return true if it contains next element. Right, next element, what it will do? It will return actual value of the element. Actual value of the element. Right, vector and stack both have, right, vector and stack both have, right, we can create a stack object like this also, right? Because the stack is the, what is the parent of stack? Vector, right? Stack so by using parent we can create a stack object also, right? Vector and stack both have, these are all two legacy classes. So these two have elements, enumeration object. Right, in the interview maybe we can also get this question, right? Enumeration. It has, then we can iterate by using has more elements, next element, has more element, next element. All right, this is one thing. And we will see one more interview question. Fail safe iterator, fail fast iterator. Fail safe and fail fast iterators. We'll see that what is that. Okay, we'll create one more class. Iterator section. Main method. Fail fast. Look, we'll create a list object. List iterator, and then we will add list object, and then we will create the array list object, and just we will add some elements, and then we'll try to print. Right, we'll try to print this. Right, we can use the for each loop. Right, we can use the for each loop. And then while iterating, I want to remove the element 102. Okay, 102. Right. 102. If ID equal to 102, right? If ID equal to 102, right? I want to remove this element. One more bracket. Okay. Like this, I am trying to, by using for each method, I am trying to remove one element. Right? Element ID dot remove. Just passing that ID value. Right now, try to remove it. To run it. Right, we will get a concurrent modification exception. Right, concurrent. Why we are getting while iterating, right? While iterating, we are trying to remove the element. Right, while iterating parallelly, we are trying to iterate or remove. We are trying to remove the element. So it will not allow. So it will not allow. It will throw a concurrent modification exception. This is called a fail fast iterator. Right, fail fast iterator. Now I want to remove it. How to remove it? We can achieve by using fail-safe iterator. By using fail-safe iterator, we can achieve it. Right, fail-safe iterator. Same thing, we will do it by using iterator. Okay, by using same thing, we can, right, we can do like this also iteration. Right, previously we have done while loop, right? This is the lambda expressions. Employee ID dot iterator. On the iterator, we can do for each remaining, each element we are iterating for each. Right, for each, I think for each also, no, it's not allowed. Only for each remaining, and then we are getting one by one element. And if ID equal to, we are trying to remove it. Right, if we are little bit confused about it, first we'll see normal. Okay, employee IDs dot call the iterator. Okay, it will return iterator. Copy this, so we can copy it. Iterator, right, IT or some name. Okay, import correct package, java.util package. Right, then while itr dot as next and then get the next element. If the element is something 103, remove it. Right, then print it again. Once we remove, then print the employee IDs. Right now run it. Okay, we got exception and it got break. Right now, if exception is occurred, I want to continue to this loop. How to continue? Right, how can we achieve it? I want to continue. If error occurred also, I want to continue this program. Right, how to achieve? Anyone? Anyone? Right, keep it inside a try and catch block. Right, keep it in a try and catch block. Don't do anything. Right, don't do anything. Just print, just a message. Right, it will continue. Right, see, we got exception. Still, we are continuing further. No, here, how many times we have done? 1 second. Got a multiple things. Okay, keep this in. Okay, then iterator, right? Okay, fine. 101, 3, 4. Right, we got removed 103. Right, it got removed 103. 101, 104, it got fit. And by this is the fail safe iterator. Right, if you try by using for each loop, if you try to remove it, we cannot. Right, we cannot remove the element. We cannot. Right, we have to use the iterator concept while doing iterator. Right, we have to remove on iterator object. Right, if you observe here, we are doing remove on iterator. Whenever ID becomes 103, we are removing on the ITR object, not the list object. If you try again here list object, it will fail. List dot remove. If you try that, it will not work. We have to remove on ITR because right iterator has a remove method. Right, iterator has a remove method. Right, so like this fail safe iterator. Right, interview so we may get this question also. What is fail fast and fail safe, or when we will get a concurrent modification exception. These things. Right, we can use this one. This is the right somewhat little bit right lambda expressions. Employee IDs dot iterator, and then for each remaining. On iterator we have a for each remaining. Right, iterator class we have a for each right remain this. Right, by using that we can iterate one by one ID, and then whenever ID is 103, we can remove it. Right, this is also iterator concept, same concept only, whatever we are doing here, but we using lambda expression. Right, fail safe and fail fast iterators. Right, fail safe and fail fast iterators. Right, and one more thing, one more interview question we may get. Right, suppose. Okay, representation hierarchy. Okay, collections, just go to here. Okay, set will not allow duplicates. Right, set will not allow duplicates, but we will get an interview question like very class is not showing. Okay, let me copy. Okay, I'll create a one the employee class. Okay, employee class. Okay, employee class int employee ID, employee name. Right, just these two. Okay, constructor. Then we assign the values to the instance variables constructor. Right. Now main method will create a set of employees. Okay, set of employees. Now I'm adding some employees. Employees dot add new employee. That we are adding multiple employees. Right, multiple employees. Here I have added duplicate elements. Right, in interview they will ask if we use the custom object. This is the object, our own employee object. This is not a Java like a string or integer, not a byte short. Right, we are using our own objects, employee objects. Here, these two are duplicate. Right, what is the set feature? Set should not allow duplicates. Right. If I print, what will happen in interview question? They will ask. Right, is it removes? Is it remove? or not? Okay, let me. Okay, let me print it. Okay. Right, why it is? Can you mute on it?
Sir, here the values is
Yeah, Jyoti, you are only speaking. Yeah, just yeah, you can unmute and ask the question you are asking. Yeah, someone speaking. Yeah, you can unmute and please speak.
values here we have given key and pay values. Sir. Set can accept that one.
Where is key and value?
Sir, here one and
This
that
is
name.
not key. This is not key and value. This is only one value. Just employee object. This is employee object. This is not. This is not key value. Right. We can create actually employee object. Just to mute it. Just to mute it. I think background noise was coming. Right. Actually, we have to.
Yes, sir. Got it. Got it. Sir. Got it.
Right.
Thank
This
you.
is only
Yes,
a
yes.
simple object. Okay. Okay. Can you please mute it, Jyoti? I'm getting a lot of break. Okay. Thank you. Yeah. This is like a single, not a right. Got it. Right. Then, if you print it, whether it will print duplicates or not. All right. Okay. We have executed, right? It is printing some hash code. Right. This is printing some class name with the hash code. All right. To print the content of it, in the employee object, right? In the employee class, we have to override the. We can write like source to string method. Right. To string method. Right. We have to override to string method. It is calling by default object class toString. If you call object class toString, it will print the hash code. So we can just run it. Now it will print. Right now it will print. Right, it is printing in the single line. I am not understanding what is that. Right, just will print. Okay, we can use for actually right like this. Right, it is printing all the elements. Right, it is printing all the elements. It's not remove duplicates. It's not removed duplicates. All right, suppose if I use tree set. What is the tree set concept? It's short actually. Right.
Execute alphabetical.
Right. But how it will sort on what basis it will print, whether it is a ID, whether it is a name, right? We are getting class cast exception. What is the wrong here? Okay. Employee cannot be class to comparable comparators. Okay, right? See, it is unable to sort it. First of all, it is unable to sort it. To sort it, we have to do something. Right, this is unable to sort it. Reset itself is not working. Class cast exception we are getting. Cannot class employee to something comparable it is saying. Right, we can go with hash. Right, now the concept is it is not sorting. This is the interview question they will ask. Then how to sort it that we will see later. Those are all we'll see later. Right, fine. This is it will not sort. If we add the user defined objects, it will not sort. Only it will sort byte sort all the primitive types, all the wrapper classes, basically all the wrapper classes and string. If we add the string, it will remove the duplicates. But if we add the our own objects, employee objects, student objects, right, like that, it will not remove. It will not remove the duplicates, right? Okay, just you can verify why it is not allowing. Later I will tell you in the advanced concepts. Once we start the right core Java, we will complete it by using map. We will start advanced topics after this. Then I will tell you all the advanced. Okay, fine. This is one more thing. Right now, actually, we'll come into our topic back. Right. So far, we have seen collection on the collection interfaces. Okay, I want to tell you queue also. Just not high level, just high level. I will tell you. Right. Collection has a three interfaces. Actually, three sub interfaces. One is the we have learned. One is a set. One is the list. One is the queue. Queue also a one of the child interface of the collection. And quickly we'll see queue. Right, queue implemented classes about linked list also comes under queue. It will comes under both list and queue. List will right implements both list and queue. All right, we will have a something called priority queue. Right, and then DQ, DQ. Right, we'll see. What is the queue first of all? Right, we have seen stack. Right, stack means what? One by one. It will right like this one by one. We'll keep books on one by one or right. That means right last in first out. Right. If we keep the books one by one, whatever we kept last, we will pick the first. But in the queue means right, we will go like this. Right. Who comes first? Right. They will only go first. Right. First in first out. Who comes first? Right. We can call it as a stack is LFO. It will follow the right last in first out. LFO. Here queue will and then first in first out. Who will come first? They will go first in first out. Right. That is the call of queue. Right. Just we'll see why it is not showing for me. Other package. If we don't show, we have to go like this. Package and then queue. Then we'll quickly create a class. Okay. Queue example. Please mute who are not muted. Right, man. And then what are the queue implemented classes? One is the linked list. Queue of integers. Suppose if we create like this, what will happen? Right, this is not a, this is an interface, right? Queue. Queue as an interface extends collection interface. We cannot create object. Right, we can create by using linked list. Right, linked list is the one of the implemented classes. Suppose if you click on linked list class, if we go to here, if you see, it will implement a list interface and a DQ also. DQ also interface, that it has a queue again, parent. But queue interval linked list will act as a both list and a queue. Alright, what it has then? Queue, what it will have? Let's suppose queue dot. Right, we can instead of add, what else we have? Okay, we'll see that. All right, we will see. Okay. Okay, only few methods are there. Okay, one is the add. We know that I am not going deeply. Right, queue, and then add all we know. If you want to add one, let one collection to another. Then queue dot contains all. Okay, element. We have this is a special one. Right, element. We'll see what is element, and then offer, peak, poll. Okay, remove we know. Right, clear we know. Empty we know. Size we know. Right, these are all we know. Contains all. Right, these are all we know. Right, here special ones are these above ones. Q contains, these are all the special ones. What is the element will do? Element will retrieve the element head of the queue. Right, head of the queue. Suppose we will add few elements here. Okay, quickly. Okay, fine. Then we'll print it in a system.out.println because it is returning element, so we can print it in system.out.println. It will return the head of the element. What is the head of the element here? It will follow the queue, right? Right, first in, first out. Right, element. It will return the head of the queue. It will not remove any element. It will not remove any element.
ईश्वरवाद को कभी नहीं लेना चाहिए, क्योंकि जैसे ईश्वरवाद लाएंगे तो हम पैरासाइट बन रहे हैं, उन पे डिपेंड कर रहे हैं अपना 100%.
Pure, please don't unmute it if you don't speak. Right, queue just will print the queue. Right, after element, it will not remove. That is the important thing. Element just will return it. It will not remove any element. Right, then offer. Right, insert the specified element into the queue if it is possible to immediately without violating the capacity. Okay. Let's suppose I'm trying to add 50. Okay, just again print the queue. Let's see, it is added 50. Right, offer, by using offer, we can add the element to the queue. The element we can retrieve there, and then peak. Peak also retrieves. Peak also retrieves. Peak also will retrieve the element. Okay, again print it. Again print the element. Right, just it is returning the head of the element. It is not removing anything. Now coming to poll. Poll will retrieve the head of the queue and removes it. It will remove from the queue. Actually, what is the return? Okay, returning integer. Right, it will return and remove. That is the difference between peak and poll. Right, okay, I did not print it. Okay, see, it got removed head of the element. It is returned and removed. Right, that is the poll. Poll will remove head of the element. Peak, we will just retrieve the head of the element. Offer will insert the element also it will retrieves, but it does not remove the. Okay, fine. These are the specific methods to the queue. Right, first in, queue is first in, first out. Right, then there is a one more queue. There is a one more queue, priority queue. Right, priority queue. Priority queue will not follow the first in, first out. It will not follow the first in, first out. It will not follow. Right, what it will do? It will do on the priority basis. Right, it will do priority basis. Sorry, I did not change it, right? Priority queue. Okay, priority queue. Let's see, it will display in a order. It will priority queue will display the list in a order, priority wise. Right, it will give priorities for the lowest one first. It will insert the lowest one first, then follow the order. Follow the order. Right, lowest one first. Then right, element means it will retrieve top element means what? Not the in this order. Right, here this is the order 10, 20, 30. Right, this is the, it will follow order, sort right, priority order. Priority order means lowest one is the first and then continues it. Right, that is the difference between the queue and queue will follow, linked list will follow first in first out. Right, whatever order we allow, it will follow it. But priority queue will not follow that first in first out. It will follow based on the priorities. Lowest one has the highest priority. Lowest one has highest priority. So it will as a like a ascending order. Right, like ascending order. Right, just this is a high level about the priority queue. Right, queue and priority queue. We can have something array DQ. Right, also. Now coming to our actual one, map interface. Just we'll see, go with the map. What happened suddenly? My keys. Right, right, map interface. Right. So far we have seen under collection different types of interfaces. All the collection implemented classes will allow to store group of objects as a in a single object. If you want to store the group of objects in a single object, but a map object is, it is not under collection. This is separate root interface. Map is not under collection. Right, it is separate root interface. It is separate root interface. Right. Why we will use map? To store the key value pairs. To store a key value pair. Suppose I want to store student ID with the student marks or student name with the marks. Right. I want to print, sometimes in interview we will get, they will give some string. Count the each character how many time occurs. Right. Famous question. Right. They will give a string. Count each character how many time occurs. In that case, what we will do? We will keep it in a map. Key as a character, value as the how many times. Suppose A repeats 2 times. B repeat 1 time. C repeat. Right. We can, by using the map, we can achieve it easily. Right. Map is used to store a group of values as a key value pairs. Group of values as a key value pairs. That means key will be their value. Key can be anything, value can be anything. Right. Either it be string, integer string int, anything we can take. Anything we can take. Right. Under map we have a, right, under map again, what are the implemented classes? We cannot create object of map because it is an interface. Right. We will have a HashMap, linked HashMap. And then here we will have a one more interface called sorted map. And then we will get a tree map. In the set also same structure will work. It is basically like a set, looks like, right? Hash set, linked hash set, tree set, right? Similarly, right? A tree map. And then we have a one more legacy class, hash table. Legacy class, hash table. It is also under map. Right? It is also under map. And also we will use the properties. This is also if you want to read the property file. Right, this is also a map implemented class only. Right, hash table properties, these are also. Right, legacy, this one is the hash table is the legacy class. Right, these are all map implemented classes to store the group of values as a key value pairs. But just quickly we'll jump into example new package. A map interface. Okay, under map. Okay, we'll create with we'll start with the why it is not showing today. Okay, class hash map example. Okay, hash map example. Not the class. Class, click on the class hash map example. Okay, now quickly create the main method. How to create it? Map. We have to use the generics and then follow. Right. You can give anything. Key can be anything. Value can be any type. Any type we can give. That is here just we are taking student ID. Otherwise we'll take like a student name with the marks. Okay, marks. That means float. We'll take float or double. It's better to take double. Right, student name with the marks. Right, just will give it as a student marks. Right, key value pair. Key can be anything. Value can be anything. Just right, we can store by using put method. Right, if you want to add here, no add method. Put. We will call it as a put method to add the data into the map. Right, what it will follow hash map will not suppose if we added duplicates. Right, if we add the duplicate, what will happen? Let's see, it got removed duplicate. That means duplicate keys cannot be allowed. In the map, what is the feature of the map? Duplicate keys. It will not allow duplicate keys. It cannot have duplicate keys. It can have duplicate values. Right, values can be duplicated. Two students can get same marks. Right, but keys cannot be duplicate. It will remove it. If you add it, remove it. But right, one more thing also we'll see that. Right, here it will not allow duplicate keys. It will allow duplicate values. Right, then interview they may ask, is it allow null keys? Right, null keys. Because it will not allow duplicate keys, it will allow only one null key it will allow. If we add one more thing, it will right remove it. Right, so it will allow only one. Null values any number. We can add multiple null values. But a key can be only one. This is only interview for a real time. We will not do these things. Right, one null key or more than one null value, it will allow. Duplicate keys, it will not allow. Values can be duplicated. Right, what will happen if we try to add duplicate? It will override the previous value actually. Suppose here LS is there 85.5 the marks are. But now again I have added with 90. Now what it will do? Actually it will override. That means previous value will be overridden with this. Right, that's why we must be very careful while adding the keys. If we add duplicate keys, it will override the previous value. Right, fine. And then if you want to put, okay, put we have seen what else other methods. Put all. put if absent. This is also one more famous. Right, put if absent. That means what we are telling. Suppose you are trying to see same thing if you are trying to give override. Okay. Previously, what happened? It is overrated the value. Now, if I give like this, we can make sure that put if absent. That means if key is not there, then only add it. Otherwise, don't add. Right. We can make sure that value will not override. If already key is available, it will not add it again. Right. We can make sure that it will not override. That is the difference between put and put if absent. Right now, right, put all means if you want to add one map to another map. Right, if you want to add one map to another map. Suppose if we have a one more map, right, student marks one, maybe. Right, here we'll take alias one, Bob one. Right, then add student marks here. Now what will happen? These are all will add to student marks dot put all. Something here. This one we have to keep it above. Here we have to keep it while copy paste just to make sure change the variable names. Right, otherwise incorrect results we will get, we will not understand. Right, what happened here? Alias one, Bob one also added. Right, it will not preserve the order. Right, HashMap will not preserve the order. It will print in a random order. Right, see, we have added in one order, but it is printed in one order. Right, put all to add the one map to another. Right, if you want to try to access the values, student marks dot get off, pass the key. Right, here there is no index concept. Just we have to pass the value. Either we can pass get, we can use the get key. If we pass the key alias, right, alias, then it will return the marks. If you pass the student name, it will return the marks of the student. Right, it will return the marks of the student. Right. And one more thing we have, right, get or default. Get or default. Suppose I am passing Bob. Suppose if it is not there, what to return? Right. In the above case, what it will return? Let's suppose we'll see. In the above case, suppose I am giving 1 1. Right. There is no student with this name. What it is returned? Null. Right. Instead of null, right. Instead of null, I want to return. Suppose if it is not there, I want to return 0 marks. Right. 0 marks. Right, right. If it is there, it will return the marks of the student. See, Bob is there. It written 92. Suppose Bob 1 1. That there is no student with Bob 1 1 1. It will return 0. Right, it will return 0. Get our default. We can also pass default value if the student is not available. Right, that is the get and get our default. Right, and then right, we have a remove. Right, remove. If we want to remove method is there. We can pass the key. Right, we can pass the key. It will remove it. If we pass the key, it will remove it. Right, just if we pass it, right, it will remove this Charlie. Right, whatever we have passed, it will remove. I think it's removed already. Charlie. Right. And then student marks dot right remove. I think only remove. We can pass the key and also key and value. If you want to pass right key and value also we can pass. Sometimes right yeah key Charlie value That value is an integer. Right. What is the marks of Charlie? This 70. Alright. What it will do? It will removes Charlie only if the value is 78.0. That if Charlie has 78.0, then only it will remove. Right. Otherwise, it will not remove. Suppose if I add, it will remove it, Charlie. Suppose just one, that 0.1 we have increased. That if you see, it's not removed. That if it matches both key and value, then only it will remove. Otherwise, it will not. But above this one, it will, if it matches the key, it will remove it. It will remove it. Right. When, and then what else we have? Clear. At clear we will know, right? Clear to it will clear the all the elements of the map. That means it will remove all the elements. That it will be empty. It will become empty. Now if it become empty, we can use the isEmpty method to verify map is an empty or not. Map is an empty or not, isEmpty method. And then we have a size method, right? To get the size of the map. That actually we have to use this above. Okay. Right. What is the size of the map? Right. What else we have? Okay. We'll see contains. Okay. Equals getter default is empty. Key set put down. Remove we have seen. Okay. Few more. Replace. Right. Replace. If you want to update. Right. Just if you want to update. That I want to update. Suppose Bob1 with some other value. Right, we should not use that put method. Right, put will replace. It will replace, but that is not the actual. Right, that will. We should not use the put method. Right, here we have to use the replace to replace the existing value. Suppose we got one. Right, just comment it out. Clear method. Otherwise, right. That it will replaces the value whatever previous. We can also replace, right, by using key and value also, right? Replace method is there, overloaded methods, right? This is the concept of overload. See, method name will be same, but arguments will be different, right? What is the old value and then new value, right? It is replaced with 120, right? We have to give this is the old value and new value may be 150, right? We can do if it matches old value correctly, then only it will replace. Otherwise, it will not replace. It will not replace. Right? It is replaced with 150. Right here, mainly put method to insert the key value pair, get method to retrieve the value, remove to remove the key, replace to update the existing. All right. Okay, fine. Then we have a contains key, contains value. That contains key, contains value. If you want to verify key is available in the map or not, I want to verify particular student is available or not. Right, contains key. We pass the student name, pass the student name. Right, if it is there, it will return true, otherwise false. Similarly, contains value. Right, I want to verify whether particular value is there in the map or not. Contains value. If it is there, it will return true, otherwise false. Contains key, contains value. Right, these two are there, so it is returning true. If these are all not there, it will return false. Contains key, contains value. Right. What else we have important methods? I think these are the important methods. And then we have a iteration, very important. Iteration we'll see tomorrow. That there are a lot of iterations we can do on the map. In interview, mostly asked question, definitely will get iteration on the map. Right. These are the some of the methods in the map. Right. Any questions so far? Right. If you don't have anything, right, we'll good with the meeting. We'll meet tomorrow same time.